Hello everybody. Today we're going to tackle a relatively simple problem. I want to turn on my computer over the internet. So what's the first step? A Google search? Absolutely not. Engineers know everything. We're going to go ahead and slide into DigiKey's DMs and make us a circuit board that connects a Raspberry Pi that is connected to the computer's power button that is also connected to the internet. Let's get started. First things first, let's order up a couple of Raspberry Pi 0Ws, Ws, whatever. These will be perfect low power, always on devices, and you can pick them up from Amazon for about $20 bare bones or $32 for the full kit. While those are in the mail, we'll go ahead and get started on PCB design. I'm starting with a simple solid-state relay that will emulate a button press. It needs a connector to interface with the GPIO header of the Pi and a connector to hook into the jumpers coming off the motherboard. It is also important to me to have LEDs, but these are optional. Much like my silk screen, I'm spending way too much time designing this, but hey, it's art, so we're going to go ahead and charge our client $0 for the hour we're spending on this task. I can get them under a week from PCBWay, and for a total cost of around $25 for 10, putting them at $2.50 per board sans parts. We'll need to order a jumper splitter and some jumper wires from Amazon. While we weren't looking, the Raspberry Pis magically showed up and got DiaPi OS, Python 3, Mosquito MQTT, and Paho MQTT installed on them. Originally, I was going to use my AWS Lightsail instance to act as an MQTT broker, but I had no such luck after dumping a couple of hours into it. In an effort to keep things cheap, I opted for an AWS EC2 instance that falls under the free tier. This gives me 12 months of a 100% uptime server that will act as my broker. If I want to continue using this service, I can buy a year's worth of server for about $50. A small price to pay to be able to access my personal copy of SolidWorks. You can use another Raspberry Pi for this and open up the ports on your router, but that's way too much system admin work for me and my proof of concept. Now, I'm going to write a simple Python script that subscribes to comp_stat/reset control and comp_stat/power control from the MQTT broker. When either receives a message, it will activate a circuit on my solid-state relay and short out the power/reset pins on the motherboard. It will also reset the 1 back to a 0, indicating to the user that the task has been completed. Fast forward a couple days, and I have now received my super awesome PCBs from China. Let's put them together using my super snazzy TS100 knockoff. Whenever I'm soldering SMD components by hand, I always make sure to tin a single pad for each component. This makes assembly easier, since I don't have a hot air setup. And hey, presto, all of that pain has been converted into a circuit board. Let's go see how it works. First, I'll write a little script that toggles the GPIO pins so I can make some measurements. Look at that, 30 plus ohms. That is absolutely awful for anything else other than what we're doing. But it should work. Now let's do a test using my smartphone and send a message to the MQTT broker. The Python script on the Raspberry Pi should read the message, toggle the LED and solid-state relay, and reset the 1 to a 0. Hey presto, that works. Okay, let's install it on the PC using the power button splitter and some jumpers. Now that it's installed, I'm going to do a quick test to see if it works. Moment of truth, and power up. I have a few boards left over. I'm sure if you asked me nicely, I'd send you one. If you're stubborn like me, the design files will be on my blog, www.farnsworth.engineering. And you're more than welcome to make them yourselves. There will also be some more details available on the gotchas of this project. With any luck, I plan on releasing a few more videos with some more complex projects coming up. It's good to be back. Until next time, this is Conrad Farnsworth.